Welcome to AI Frontiers. Today's episode explores the robotics revolution through 31 papers published on November 5, 2025. We'll journey through cutting-edge autonomous systems, from Mars landers to humanoid soccer players, revealing how computer science robotics is transforming our world. This presentation provides an overview of the future of embodied intelligence. The journey will explore today's robotics breakthroughs, discover how robots are becoming true partners, examine fault tolerance for space missions, witness human swarm teaming advances, and understand the methods driving this revolution. Computer science robotics represents the fundamental intersection of artificial intelligence, engineering, and computer science. This field creates machines that perceive, reason, and physically act in the world. The scope extends beyond factory automation to real-world adaptation, spanning from microscopic surgical tools to massive construction systems, all demonstrating embodied intelligence across multiple scales. Enhanced autonomy represents a major research theme focused on closing the human-robot attention gap. Kailun Ji and colleagues used large language models to control drone swarms with natural language commands. Azizola Taheri's work enables robots to follow high-level spatial commands. These advances move beyond simple navigation to complex reasoning, allowing robots to understand multi-step instructions in plain English and bridge strategic goals to tactical execution. Robustness and fault tolerance form another critical research theme, building systems that don't fail when it matters most. Kyongsik and team developed the ARBITER system for space computing, performing real-time fault detection across redundant processor cores. Meanwhile, Jack Zeng demonstrated drones that adapt when teammates fail, dynamically redistributing loads during flight. These capabilities prove critical for high-stakes space and rescue missions. Human-robot collaboration represents a transformative theme where robots evolve from tools to true teammates. Chenzui Li's research shows robots optimizing their posture for human comfort during cooperative tasks. Aniol Civit developed robots that mediate human preference conflicts, while Zhihang Qin enabled force-based assembly without vision. These systems demonstrate understanding of human context and ergonomics, acting as partners rather than just tools. Reinforcement learning serves as a fundamental technical concept where robots learn complex behaviors through trial and error. This approach is used for soccer skills, drone coordination, and assembly tasks, discovering successful strategies in simulation. The primary challenge involves transferring policies to the real world, known as the sim-to-real gap. Research by Yuxi Wang and colleagues demonstrates this gap is narrowing successfully. Transformative performance gains represent key findings across applications. Space computing achieved 250 times faster trajectory optimization in work by Yun and team. Human swarm interaction showed 64.2% faster task completion in Ji's research, with 42.9% reduction in operator cognitive workload. Embodied AI advances include unified vision-to-action controllers, delivering mission-critical reliability with performance scaling. Methodology synthesis reveals the tools powering robotic intelligence. Reinforcement learning enables trial-and-error skill acquisition. Model predictive control provides real-time optimization planning. Imitation learning captures knowledge from human demonstrations. Learning-enabled model reduction creates simplified physics models, while cross-platform virtual reality teleoperation facilitates high-quality data collection. The selected paper on fault-tolerant space computing by Kyongsik and colleagues addresses autonomous planetary landing. This research tackles critical computing for radiation-heavy space environments using ARBITER, a multi-core voting system for real-time fault detection. Performance improvements include 15 times faster image processing and 250 times faster trajectory optimization. The work identifies vulnerable gradient computations and landing algorithms and provides a blueprint for future deep space mission autonomy. Another seminal paper by Kailun Ji and team explores LLM-based human swarm teaming for search and rescue operations. This research enables natural language control for drone swarms, with large language models bridging the intention-to-action gap for operators. Results show 64.2% faster task completion in rescue scenarios and 42.9% reduction in NASA Task Load Index scores. This approach transforms emergency response through cognitive offloading. Yuxi Wang's research on vision-driven soccer robotics addresses the humanoid soccer challenge. Their unified controller maps vision directly to action using reinforcement learning with adversarial motion priors. The system demonstrates robust performance in dynamic RoboCup matches, closing the perception action gap in complex environments. This represents a significant step towards seamless reactive biological-like competence in robotics. Model predictive control serves as another fundamental technical concept, enabling planning ahead in dynamic environments. This method constantly solves what happens if scenarios, implementing the first step, then recalculating with new data. It proves ideal for handling constraints and uncertainty, used for both human-robot interaction and soft robot control. The primary limitation involves computational cost restricting the planning horizon. Future directions and challenges outline the next frontier in robotics. Key areas include foundation model integration with safety verification, closing the sim-to-real gap for learned policies, and scaling to thousands of coordinated agents. Ethical frameworks for human preference navigation will become increasingly important, alongside developing generalist robots for open-world task diversity. This presentation was synthesized using GPT DeepSeek chat model, with text-to-speech processing via DeepGram and visual design concepts using Stable Diffusion. Human expert review was conducted for accuracy, with potential oversights acknowledged and references provided for further investigation. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv preprint server.